This is, 5.5 is indirect reasoning. Okay, so yes, we are doing proofs. No, they are not two-column proofs. Yes, they are simpler than your two-column proofs. So don't worry about that. What indirect reasoning does is basically instead of saying, here's what I know and here's why I know it, and here's what I know and here's why I know it, and here's what I know and here's why I know it, now we say, here's what we're trying to prove. Well, there's three options. I know this one's not true, and I know this one's not true, so by process of elimination, it must be this. Okay, so indirect reasoning is going about it an indirect way. We're not going straight to what we're trying to prove. We're eliminating what we know we can't prove, and what we're left with is what we're trying to prove. Okay, so indirect reasoning is what we're doing. For an indirect proof, there are 3 steps always. Okay, the first one is if we're really going to prove it by contradictions, by basically process of elimination, the first thing you have to do is you have to assume temporarily. We're just going to say assume. Don't worry about the word temporarily. Assume the opposite, which the book calls the negation of what we're trying to prove. Okay, assume the opposite of what it is you're trying to prove is your first step. Step 2 is you're going to show the assumption leads to contradictions. I promise this is where most of the writing comes in. There won't be a 10 after this. And then from there you conclude the assumption is false. And you restate what you're proving. Okay, so first step, assume the opposite. Second step, show that that assumption that you made leads to some contradiction. And then your third step is, okay, because it led to contradiction, then the assumption was false, therefore, and then you just restate what they asked you to prove. Okay, so that's kind of the process. The good news is I will never make you give me a full-on proof in any quiz or test in this chapter. We just decided we're not going to make them do a full one. Instead, we're going to break it into parts. So we might ask you, what's the first step of this proof? What would the first step be? Or we might give you a list of things and say, find the contradiction. But rarely do you have to do a full-on proof. I think there's like maybe 2 in the homework where you have to prove the whole thing to me. Most of the time, we're just going to break it up for you into pieces, okay? So here's how we do it. Example 1. I want to know what would the first step of this proof be. Okay, so if I told you prove that quadrilateral XYZA does not have 4 acute angles. Okay, I just want to know the first step. What did it say you do for the first step? What was step 1? Yeah, Angelina. Assume the opposite. Assume the negation, okay? So step 1 of this proof, you have to write the word assume, okay? If you don't write the word assume, it's wrong because what you're going to assume is not true. So you can't say it's true. You have to say assume for a second that it's true, even though we know it's not, okay? So your first step is assume And then you got to think, what is the opposite of this statement? So if they're saying quadrilateral XYZA does not have 4 acute angles, what do you say, Aaron?
Assume quadrilateral XYZA
Has 4 acute angles. So you say assume quadrilateral XYZA has 4 acute angles. Okay, now normally if we were going to do the whole proof now, we'd say, well, find a contradiction to that. Well, a quadrilateral cannot have 4 acute angles because the biggest acute angle you can have is 89 degrees, and 89 plus 89 plus 89 plus 89 will never add up to what a quadrilateral has to add up to, which is 360. So there's your contradiction, okay, step 2. Step 3, the assumption's false. Quadrilateral XYZA does not have 4 acute angles. That would be the full proof, okay? Right now, we're just looking for what is step 1. So this is your step 1, all right? Okay, so if I said, given integer n, prove to me n is divisible by 2, what would your first step be? Okay, but with the assume first, right? So you have to say assume n is not divisible by 2, right? So just assume and the negation, and that's your first step every time. Questions on that? Okay, then we're going to look at some contradictions. Example 2. Let's say I give you these 3 statements. Statement 1 is triangle ABC is acute. Statement 2 is triangle ABC is scalene. And statement 3 is triangle ABC is equiangular. Sorry, that's messy. In those 3 statements, there's one statement that does not work with the other 2. There's 2 statements that don't work with each other, I guess is a better way to say it. Which 2 statements contradict each other? In other words, can you have an acute scalene triangle? Can you have a scalene equiangular triangle? And can you have an acute equiangular triangle? Which 2 can't happen at the same time?
First one and the third.
You can't have an acute triangle that is equiangular. You can't have a scalene triangle that's equiangular. Which 2 can't happen together?
1 and 2.
You can't have an acute triangle that's scalene. Angelina. You can't have a scalene that's equiangular. Okay, think about that. What does scalene mean? All of your sides are different, right? Scalene means all your sides are different. Equiangular is always what? Equilateral, right? So you can't have an equilateral triangle that's also scalene. Equilateral means all the sides are the same. Scalene means all the sides are different. So your contradicting numbers here would be 2 and 3. Okay, so you have to think through, can these 2 go together? Can these 2 go together? Can those 2 go together? Okay, and pick the 2 that can't. So that's contradiction. How about if I said you have a triangle that is acute. You have a triangle that is scalene. And you have a triangle that is obtuse. Which 2 can't go together? 1 and 3. You can't have acute and obtuse, right? Because acute means all acute angles. Obtuse means you have one obtuse angle. So you cannot have, if this was 1, 2, and 3, okay, 1 and 3 can't happen at the same time. So you're just looking for where do they contradict. Do you have a question, Noah?
What is scaling?
Scaling means all three sides are different.
But you also cannot capture acute and equiangular.
Acute will be equiangular. Because equiangular means you have 60, 60, and 60, right? So if you have 3 60-degree angles, those are all acute angles, right? Okay. Tell me what's wrong with this. You're going to write an indirect proof that shows angle X is an obtuse angle. Okay, so if it says prove angle X is obtuse, what's wrong with me saying as my first step, assume angle X is obtuse? Sorry, is acute. So if I said for my first step, assume angle X is acute. It could be right, right? It could be, it's not covering every possible option. So you don't want to say this. You want to say what instead? It's not obtuse. Okay, that means it could be anything else, but it's not obtuse. So assume angle X is not obtuse. Don't say assume it's acute. Don't just pick a different type of triangle there. Okay? Okay, here's what we're going to do. I am going to walk you through one full proof, and then we're done. Okay, so it says given that 5 times x plus y equals 50 and x does not equal 3. We want to prove y does not equal 7. Okay, so if we're going to do a full proof here, step 1 would be what? Assume what? Okay, you don't assume from the given, right? You assume from what they're asking you to prove. So assume y equals 7, right? If they're saying y does not equal 7, you say assume y does equal 7. Okay? So we plug it in. Step 2 is we got to find a contradiction. Well, let's say if we're assuming y is 7, then it's 5 times x plus 7 equals 50. If we solve that, divide by 5, we get x plus 7 equals 10. How do I solve that? Take away the 7, x equals 3. Okay, well now look at our proof. What is wrong with this? X does not equal 3, right? They told us here, x is not 3. So here's your contradiction, right? We solved for our assumption, and it said x equals 3, but x can't equal 3. Okay? So that's a contradiction. Therefore, we say the assumption is false. Y does not equal 7. Okay, so that'd be your third step. The assumption's false. Restate what they asked you to prove. Questions on that? Okay, I'm just going to talk you through one other one real quick. We're not going to write this out because it's a lot of words, but I want you to just see a different scenario where it's not algebra, it's more a situation. Here's the problem. It says if Jaylene spends more than $50 to buy 2 items, okay, more than $50 on 2 items, then at least one item costs more than $25. Okay, so given that the cost of 2 items is more than $50, we have to prove that at least one item costs more than $25. What's the opposite of that proof? Assume neither item costs more than $25, right? Okay, so if neither item costs more than $25, then the most we could spend is $24.99 plus $24.99, which is $49.98, right? The proof said at the beginning, Jaylene spends more than $50. So if we only spend $49.98, did we spend more than $50? No. So there's your contradiction, right? It doesn't work. So you say the assumption is false. Jaylene must spend more than $25 on one item. Okay? So that's kind of the wordier version of a full-on indirect proof versus the algebra version of the proof. Okay? But look for contradictions. You're just looking for why will this not make sense? Are you about done back there?